ॐ श्रीगुरुभ्यः नमः। सर्वग्रे नमस्करोमि अत्र उपविष्टान् अत्र उपस्थितान् प्रधान अतिथि महाभागान् श्री एम.डी. श्रीनिवास महोदयान्, सभापति महाभागान्, अध्यापक पी.के. चट्टराज महाभागान्. This is my privilege to introduce Sir Professor P.K. Chattaraj. Sir is a professor of chemistry at Indian Institute of Technology, IIT Kharagpur. He received his PhD from IIT Bombay. He was a research associate in the University of North Carolina, Chapel Hill, USA, and FAU Erlangen, Nuremberg, Germany. He has been actively engaged in research in the areas of density functional theory, ab initio calculations, nonlinear dynamics, aromaticity in metal clusters, hydrogen storage, noble gas compounds, machine learning, confinement, fluxionality, chemical relativity, and quantum trajectories. He was honored with University Gold and Bardhaman Sammelani medals, INSA Young Scientist Medal, CRSI Bronze and Silver medals, IAAM Medal, Associate, Indian Academy of Sciences, B.M. Birla Science Prize, B.C. Dev Memorial Award, Institute Chair, Professorship Award, IIT Kharagpur, Professor Sadhan Basu Memorial Lecture Award of INSA. He is a Fellow of the World Academy of Sciences, TWAS, Italy, Royal Society of Chemistry, UK. Indian National Science Academy, Indian Academy of Sciences, National Academy of Sciences, India, West Bengal Academy of Sciences and Technology, and FWO, Belgium. He is a Sir J.C. Bose National Fellow. He was convener, Center of Theoretical Studies, convener, Kharagpur Local Chapter, INSA, Council member of CRSI, member Joint Science Education Panel of Science Academies of India, Dean Faculty and Head of the Chemistry Department of IIT Kharagpur. He is a distinguished visiting professor of IIT Bombay. He has published over 430 research papers, book chapters, edited 7 books, and special issues of 5 journals. Citation around 19,000, high index 67, Google Scholar citation. He is in the editorial board of a number of journals published by the American Chemical Society, Elsevier, etc. Several of his papers has become most accessed and editors' choice articles. Thank you. Pranam sir, over to you.
Yes, sir.
Okay.
Warm
So-
welcome, sir. Yes.
Okay, thanks a lot, Piyush. At the outset, I would like to thank Professor Anuradha Chaudhary for kindly inviting me to be a part of this endeavor. Now, in Sanskritotsav 2021, today's topic is Sanskrit and Natural Sciences. The literal meaning of Sanskrit is refined, and hence it was the natural vehicle and medium of expression, not only to science per se. Wherever a scientific outlook is there, Sanskrit was the major medium of language. Now, when we talk about the natural sciences, basically we consider astronomy, physics, chemistry, life sciences, art sciences, etc. And the scientists in those days, they used to write their findings in Sanskrit and often in verses. So you can see that they were doing science, they were learning Sanskrit, and they were poets as well. And the natural science in ancient India, as it was written in Sanskrit verses, they were very rich. In those days, in fact, it was considered to be within a broad envelope of philosophy. Like when we understand the, say, constituents of matter in terms of tanmatras as given by Kapila to Sankhya philosophy. Similarly, through Anus and Paramanus by Kanada, the particle eater, through the amalgamation of Naya and Vaisesika philosophy. So, although we call it natural science, that was within certain umbrella of philosophy. And today, we are delighted to inform that we are so happy that we have Professor M.T. Srinivas with us, who would take us along this path connecting Sanskrit and natural sciences. Before I introduce the speaker, I'd like to tell the audience that you just pass your questions to Professor Anuradha Chaudhary, who will collect it and forward that set of questions to the speaker. And so Professor M.T. Srinivas is a theoretical physicist by training. After obtaining his PhD from the University of Rochester, USA, he taught at the Department of Theoretical Physics, University of Madras during 1976 to 1996. His research work in theoretical physics has been mainly in the fields of quantum, optics, and the conceptual mathematical foundations of quantum mechanics. Since 1996, Srinivas has been working as a senior fellow at the Center for Policy Studies, Chennai, which is devoted to study of Indian civilizational ideas and institutions in diverse fields of public activity and exploration of the potential of these ideas and institutions in elevating the current situation of India. Since 1980, Srinivas has been engaged in a study of the Indian tradition of sciences and technologies with the conviction that drawing upon our civilizational resources would contribute significantly in making our current efforts in science and technology much more creative and relevant. In particular, he has worked on various aspects of Indian tradition of mathematics and astronomy, and also on the logical and epistemological foundations of Indian sciences. Srinivas has also been keen that Indian scientific and technological an integral part of the study and research conducted in our institutions of higher learning. Professors M.S. K. Ramasubramanian and M.D. Srinivas have recorded a set of 40 lectures on development of mathematics in India from Vedic times to the modern period under the NPTEL program of IIT Madras, which can be used as resource material for an introductory course on Indian mathematics at the undergraduate level. The videos and the slides of these lectures can be accessed at the NPTEL library. Now, with this brief introduction, I'd like to invite Professor M.T. Srinivas to share his thoughts on the topic science and natural Sanskrit and natural sciences. Professor Srinivas, please.
Namaskar. I'm very grateful to Professor Pratim Kumar Chatraj for the very nice introduction, and to Dr. Anuradha Chaudhary and her colleagues in IIT Kharagpur for asking me to deliver a talk in this very interesting session. Once I have to. So let's quickly move on to the business. I'll just summarize what I want to say. I can stop at any point. The main point should go through. The main thing I want to emphasize is the following: that the Indian tradition of sciences find their first expression in the Vedas. The Vedic corpus and the ancient auxiliary texts of Vedangas, they show great strides made in sciences, especially of language, which was considered a very important science in India, the science of astronomy, mathematics, and medicine in the ancient period. In fact, these developments led to two very important things. One was the wonderful scheme of Varna Samamnaya, that is the scheme of classification and representation of basic sounds, what are called phonemes, and the decimal place value system with zero, the system of representation of numbers with 9 digits and zero. These two were extraordinary discoveries. They made universal literacy and numeracy possible not only in India, but in many other parts of the world which got to learn them. The classical period, which followed the ancient period, say roughly from 500 before Common Era, saw the flowering of Shastras, the great Sanskrit knowledge systems. Though over time, many great texts and treatises were written in various Indian languages, it is mainly the Sanskrit source works which discuss the foundational methodology of these disciplines, and they also ensure the pan-Indian and sometimes even pan-Asian character of these knowledge systems. These Indian knowledge systems, their pan-Indian circulation and even growth were greatly hampered, especially in North India, by the 5 centuries of Islamic rule. Still, according to many scholars, there was an all-round awakening of the Indian polity as well as the Indian knowledge systems in the 18th century. Indeed, it appears as if the Indian civilization seemed to be poised for a great resurgence at that time. Unfortunately, this possibility was thwarted by the political and economic disruption caused by the British rule, especially by the British implanted system of education, which continues to be in force since the 19th century. Independent India has made great strides in the revival of its economy. There has also been a great revival of the languages of India, wherever they re-established their perennial links with Sanskrit. But the same cannot be said about the modern endeavors in sciences and various other disciplines, as they are yet to re-establish their links with the great knowledge traditions of India. So we can straight away go to the development of the science of language in the ancient period prior to 500 BCE. It starts with the Vedic corpus, the Pada Patha, Krama Patha, Jata Patha of the Vedas. They actually discovered the differences between sentences, words, stems, how to mix them. Then come the Pratishakya and the Shiksha texts. And in these, we find a perfect analysis of all the sounds of the Sanskrit language into vowels, consonants, etc. Apart from the place where the sounds originate, the gutturals, the dentals, the nasals, etc. And they were placed in a two-dimensional configuration, somewhat like the Mendeleev's periodic system. In fact, there is some indication to show that Mendeleev himself was a great Sanskrit scholar and he had seen this Varna Samamnaya. This is the Varna Samamnaya or the Varnamala that is taught almost in all Indian languages. Only today we don't teach them in terms of this is originating in throat, this is originating in the palate, this is originating in the cerebral, this is in the teeth, this is in the lips, and these are mixed. The vowels are all classified this way. The Vargiya Vyanjanas, Kam to Na, are classified this way. Some are Sparsha, some are Anunasika, some are Aghosha, some are Ghosha, some are Alpa Prana, some are Mahaprana. Then we have Antastha and the Ushmans. So this way, all sounds are organized in a wonderful way as per their place of origination. And this system of classification was very important. And in fact, it is this that informs the Indian scripts that evolved. We don't know when they evolved, but the modern Brahmi script evolved somewhere around 5th century or 6th century BC, at least in terms of available sort of records. But these scripts went much further in India. In fact, Kharoshthi, Khotanese, Tibetan, Nepali, and modern scripts in Sinhala, Burma, the Khmer script, Thai script, all of them originate from the Indian script. Of course, they could not replace the Chinese characters in East Asia, But later on, in Japan, in around 1000 AD, there was the hiragana and katakana scripts, which came from the Indian Varna Samamnaya, and even the Koreans developed what many thought of to be a perfect script in the 15th century. The crucial thing is, as Fritz Stahl points out, that all these Asian scripts were a far cry from the haphazard jumble of the ABC and the countless spelling problems that result from it in English, and this originates with Greek and Latin and all sort of related languages, where these spelling problems continue to bedevil the learning of the language. Similarly, so this made literacy possible very easily in most of the Indian world. Development of the decimal place value system again goes back to the Vedas. The Vedas use a decimal nomenclature for numbers. It's a precursor to the place value system. And then there's a long history. The Upanishads talk of zero. Panini has a zero marking. The Bauddha Nayayika philosophers use shunya and abhava. Pingala's Chandra Sutra has zero as a marker. And even philosophical works say, make use of the place value system as an illustration. Yatha eka rekha, shatasthane shatam, dashasthane dasha, eka cha ekasthane. Yatha cha ekatre is three, mata cha uchyate, duhita cha swasa cha. That is, depending on the position, the value of the line takes different values, either in the tens or in the hundreds. So this was in philosophical texts like commentary on Yoga Sutra due to Vyasa, the philosophical text of the Buddhist scholar Vasumitra. By 5th century, when Aryabhata was written, Indians presented all the standard arithmetical procedures, the algorithms, in a very, very beautiful systematic manner using the place value system. And then, of course, it moved to the rest of the world. In fact, by 7th century, it is known in West Asia and it's very highly appreciated in Syria. And by 10th century, the great Islamic philosopher Ibn Sina is saying that he is learning the Indian system of numeration, the decimal place value system, from a vegetable cell. So that is what the kind of large universal prevalence of numeracy that arose out of the Indian system, the decimal place value system. Now, in the classical period in India, Shastras, the word Shastra comes from the root Shas, Anushishta, that is a teaching or an instruction. Now, the main thing about Shastras, which are the Indian knowledge systems, which are the systematized disciplines, the texts of the Shastras, the canonical texts, they are not a collection of universal truths or theorems or postulates. The texts are largely concerned with giving a series of rules in a systematic order, and they sort of tell you various systematic procedures to accomplish various ends that the Shastra deals with. If it is the Shastra of Vyakarana, it is to derive all valid words. If it is the Shastra of Ayurveda, it is to keep the healthy person healthy and to prevent and to cure a person who has a disease. So these procedures, which in mathematics are called algorithms, but they are systematic procedures referring to any science whatsoever. They are called in Sanskrit Shastras as Vidhi or Kriya or Prakriya, Sadhana, Karma, Parikarma. So the Indian knowledge systems were always rooted in practical applications or Vyavaharas, and this allowed them a great deal of flexibility in devising multiple theories and methodologies. Now, it's a common dictum that all Shastras are benefited by the study of the two disciplines, one due to Kannada and one due to Panini. The Shastra of Kannada is actually both the Vaisheshika and the later development of the Nyaya system. It deals with the epistemology of science as well as the physics and metaphysics. And Panini's grammar, Ashtadhyayi, is considered a paradigmatic text, and this is considered the ideal that all Shastras should ultimately try and achieve. Like the elements of Euclid was thought of as the paradigmatic example of axiomatic deductive methodology, which characterized the Greco-European tradition. In the same way, the Indian tradition, which used the enunciation of Vidhi, Prakriya, systematic procedures as its basic sort of methodology, the Ashtadhyayi of Panini serves, and in fact, it has all the sophisticated conventions which are called paribhasha, governing rule formulation, rule application, rule interaction, recursive generative formalisms, which we all know today in our computer sciences. The next thing that distinguishes Indian methodology of science is the theory of Pramanas. And this arises in Indian epistemology, theory of knowledge. All schools of Indian philosophy talk of Pramanas. The Charvakas accept only perception, direct observation, pratyaksha, as the only valid means of knowledge. In fact, many people wrongly characterize Charvakas as materialists, scientific materialists. They are very pure materialists. They, in fact, deny all possibility of science. The various schools of Buddhism and Vaisheshika recognize inference, which is very basic for science. Anumana also as a valid means of knowledge. The Jaina, Sankhya, Yoga, and some of the schools of Vedanta add what is called the Shabda Pramana, which is verbal testimony of an expert, of a reliable person, or Agama, or a reliable text of the current or ancient period, also as a valid means of knowledge. Bauddhas and Vaisheshikas also recognize this, but they bring it under Anumana itself. The famous school of Nyaya, which is the basic school of epistemology in Indian philosophy, recognizes four pramanas: Pratyaksha, Anumana, Upamana, and Shabda. Now, we can see that Indian scientific texts very closely follow this epistemology. Here is an example. This is a text called Jyotir Mimamsa by the famous 15th century astronomer Nilakantha Somyaj. He is quoting Taittiriya Aranyaka to list these pramanas. Smriti, Pratyaksham, Aitikyam, Anumana Chatushtayam, Etaihi Aditya Mandalam, Sarvaireva Vidhasyate. So from Smriti, which is Agama, ancient text, Pratyaksha, perception, Anumana is the inference, Aitikyam is the testimony of the teacher about various observations he has made. And then he is explaining what these four pramanas are and how they are used in the method of determining and analyzing the motion of celestial bodies. But there is something very important in Indian theory, in Indian epistemology, that there is a hierarchy of these methods of valid knowledge. Anumana cannot contradict Pratyaksha or Agama. That is, the inference always has to be something which does not go against what you have directly seen or what reliable texts or reliable authorities have directly seen. And this goes back to the Nyaya Sutra, its commentary due to Achyayana, where he is explaining what Nyaya is. Pramana Artha Parikshanam Nyaya. That Nyaya is to examine all substances, all entities in the world, to examine them. And for that these pramanas are needed, and he is making a statement, Yat punaha anumanam pratyaksha agama viruddham nyaya bhasaha sahit. So one cannot accept an anumana which is contrary to pratyaksha or agama. Of course, if you are very sure about your anumana, then you have to go and recheck your pratyaksha or agama. But normally, anumana holds a lower level of reliability. So in that sense, the observations and the data always hold a higher level of reality check in Indian scientific enterprise than the scientific theories themselves. And the scientific theories themselves are therefore always understood to be tentative and approximations to reality. Now this is immediately you can see it in an Indian text of medicine, in Sushruta Samhita, which is the original version is around 5th century BCE. There is this very famous verse, Pratyaksha Lakshana Phalaha Prasiddhascha Svabhavataha Naushadhihi Hetubhir Vidwan Pariksheta Kathanchana. The medicines, the Aushadas, which are very well known by their observation and which are well known in their due to their natural character, one should never examine them by various arguments. Sahasrenapi hetunam nambasthadi virechet. The group of drugs called ambashtha, they will never cause purgation, even if you provide thousands of arguments for that. Tasmat tishtet matiman agane natu hetushu. So you should go and follow the reliable text and try to understand it if you are not able to understand it and seeing something in contradiction. We think again that the perception holds a status against even a traditional text. This is there in a very famous 14th century text called Shankaracharya Samhita. This is there in all ancient texts of philosophy anyway. Shankaracharya's Brahma Sutra Bhashya has a very famous statement that Pratyaksha always overrides even the Vedas. Vyadheha anuktam yad dravyam ganoktam api tatyajet anuktam api yadyuktam yojayet tatra tadbudha. So the medicines which are known to be belong to a certain group, if you find them effective for something which is elsewhere, you should use them. If you find that something that is well known in a Gana which is supposed to be used for a particular disease, if you find it ineffective, then you should not prescribe it. So it is Pratyaksha that overrides even a traditional text. The science of language developed from in a very fast way. Panini's grammar is there. You have heard a lot about that, so I will not say more about it. Panini, Katyayana, Patanjali, Chandragomin, Devanandi, and the philosophy of grammar given first by Bhartrhari in Vakyapadiya. And even in the ancient times, around the early centuries of the Common Era, you have the Pali Vyakarana of Katyayana, Tolkappiyam of Tolkappia, which are related to the Sanskrit grammatical tradition. And what is the purpose of grammar? The first Vartika says the purpose of grammar is Shabdanushasana. Now, what is Anushasana? Anushasanam Prakriti Pratyaya Vibhagena Vyutpadanam. So, to produce valid utterances by making use of Prakriti, which is what is called the Pratipadika, and to it you add various Pratyayas, and the procedures for doing it is what is given in grammar. So, grammar is a production system. It's a generative system. It generates all valid utterances. And that is how Panini's grammar functions. These 4,000 grammatical rules, together with Dhatu Pata, Dhana Pata, Linganushasana, and Punani Sutras, and also the Shiva Sutras, which give the Varnas in a slightly different order needed for grammar than given in the Varna Samamnaya. So using these sutras, Panini is able to generate all possible valid spoken forms in his time. And he is also able to state where these forms differ from the forms in the Vedas. And what was the methodology Panini adopted? This is explained by Patanjali in his Mahabhashya. He is saying one good way to characterize all valid speech forms is to list them. But that is not possible. Even for divines, not alone, let alone the humans. So when Brihaspati tried to teach Indra for 1,000 divine years, he could not reach the end of listing all valid forms. Tasmat anabhyupayaha eva shabdana pratipada patava. So listing every sort of word is not a valid method. Then how do we katham tarihi me shabdaha pratipattavyaha? So how do we then try to derive all these words that are valid? Kinchit samanya visheshavat lakshanam pravartyam. So you have to give general rules and vishesha lakshana, which is apavada, which is exceptions to those rules. And the exceptions are as important as the general rule. And again, Patanjali says, how do we know the relation between utterances and their meaning? And then, how are they understood? And the answer is, again, Vartika Katyayana, Lokata, Katham Punarjnayate, Siddhaha, Shabdo Arthaha Sambandhishteti, Lokata. And then he goes around and explains that one who wants to make a valid sentence does it out of his own knowledge. He doesn't go to a grammarian and ask him, I want to say something about this, produce a sentence for me. Like you go to a potter to produce a pot for yourself. And the philosophy of this entire system is discussed at great length by Bhartrhari. I just want to emphasize one particular principle that Bhartrhari enunciated. He says this entire grammatical system is an upaya. And he says, having used it, you can even discard it. But it is only a means for obtaining the valid utterances. And there is really no other requirement that you need to put upon it. Upayanancha niyamaha na avashyam avatishtate. So you need not say words have to be constituted only out of dhatus or only out of nouns. These are all philosophical principles. If your grammar works with one kind of framework, that is good enough. In fact, the commentator Punya Raja says that even in the case of Panini's grammar, which is known to be the most successful ever grammar written for an actual spoken language, Punyaraja says, Kaschidacharya Panini Virachitena Lakshana Shastrena Shabdam Adhikachati Kaschid Anyena iti na niyama. So if you can find another grammatical system that can do as well, even Panini's grammar can be discarded, or you can go to a different grammatical system. Now, the same kind of understanding about scientific theories is sort of revealed in our astronomy and other sciences. So here is Bhaskara 1, who is writing a commentary on Aryabhata's Aryabhatiya, and he is explaining that the planetary models given by Aryabhata should not be confused with the elements of reality. It is a procedure for calculating the planetary motions, and it's good if it if it is in consonance with observations. If it is not in consonance with observations, you have to change it, you have to improve it, you have to modify it. And so again he repeats what Bhartrhari says, Kevalam tu upeya sadhakaha upayaha. These are only means for reaching the ends that we want. Uchchanija madhyama paridhi ityevamari sputagati sadhanopaya bhutanancha upayanam naiva niyamaha uktirva vidyate. And he finally goes even to say that Tasmaryam Sarva Prakriya Asatya, meaning you don't need to definitely think of them as elements. That means that scientific theories are valid as long as they are in consonance with observation. You don't need to hold to them thinking that they give some very deeper understanding of reality. There can be much better understanding if you go and examine the theories further. So this theory of grammar proceeded in India systematically in the classical period, also later classical period, starting with the Kashika Vritti of Panini's grammar. Then there are various other commentators. Dharmakirti is a Buddhist scholar who has given a different system of grammar. Hemachandra is a Jain scholar who has given a different system. Mukta Bodha is a grammar which was used in Bengal. But there were grammars of various other languages. I had talked about the Tamil and Pali Vyakarana earlier. But there are many other Tamil grammars, Kannada grammars, Telugu grammars, and Prakrita grammars. All of them produced, starting from about 9th and 10th century onwards, profusely all over India. And they were all dependent on the Paninian system of grammar and the later developments by Patanjali, Bhartrhari, and all the scholars I have mentioned. And this Panini's grammar was respected not only in India, but in most of what we know as Greater India. Here is Itzi, a Chinese monk who visits India in 7th century. He says even in the island of Pulo Condore, it is in Vietnam, and in the country of Suli, in northern Uzbekistan, people praise the Sanskrit sutras of Panini. How much more the people should be praising it in the divine land that is China, as well as the celestial storehouse of knowledge that is India. That was the Chinese name for India. And this Itzing learned actually Sanskrit grammar for 6 months in Sri Vijaya, in Palembang, Sumatra, for 6 months before coming to India, because that's where Indian grammar was also taught. Now, the main thing is the scholars have realized that for more than 1,000 years, perhaps nearly 1,300, 400 years, there was a Sanskritic culture, a culture of all sciences and poetry, aesthetics and philosophy that sort of influenced a very large region coming from Uzbekistan or even westwards down to Vietnam, Southeast Asia. And here is Sheldon Pollock, who coined the term Sanskrit cosmopolis for it, but that word has its own problems. But he is explaining how, in a very short period, very quickly, around the early centuries of Common Era, Sanskrit migrated and became not only the language, but the entire culture, including the sciences of astronomy, medicine, and the science of grammar. They were in use in much of this Southeast Asian and portion of West Asia and little bit of Central Asia. And so this was a large region, which is Greater India. And he is talking of the Angkor Wat temple, which was built in the 12th century. This is the great temple, one of the largest monuments in the world. In 11th century, a Spanish Islamic scholar, at that time Spain was under the Islamic dominion, he is explaining how amongst the various civilizations that he knows, it's the Indian civilization which has made great strides in arithmetic, geometry, in astronomy, in medicine, and all that. So the Indian sciences were very famous all over the world. But around the same time, we see the first sort of attack on India from northwest in the first millennium end. And there, this has had a disastrous effect on our sciences, is what Al-Biruni, who came along with Muhammad ibn Qasim of Ghazni. So he says, due to our conquest, the Hindu sciences have retired far away from those parts of the world conquered by us. And strangely, he also says, Hindus believe that there is no country but theirs, no nation like theirs, no king like theirs, no religion like theirs, and most importantly, no science there like theirs, something which we cannot imagine in the kind of situation we are in today. The development of science of language went unabated all over India. Narayana Bhattacharya is the writer of Narayani in Kerala. He was a great scholar. He learned from another great scholar called Achyuta Pisharati, who wrote both in Sanskrit and in Malayalam astronomical texts. But he was also well known as a scholar of grammar and medicine. Bhattoji Dikshita, whose name should be very familiar. Kaunda Bhatta was a nephew of Bhattoji. Situation in North India was not very good. He migrated to Keladi in Karnataka, and it is a very important treatise on philosophy of grammar. One of the last great giants in grammar was Nagesha Bhatta in the 18th century, who hailed from Maharashtra, was later on in Prayag. And there are again various grammars, including a Persian grammar written during Akbar's time, based on the Poninian model. In 20th century, I think an attempt was made to write a Russian grammar similar. I will not say much about the medieval period, except to mention one great astronomer, Nilakanta, who in 16th century came up with a formulation of a planetary model, which was a modification of Aryabhatta and others' planetary model. And in that planetary model, the computationally, it was as good as the work of Kepler, which was to come 100 years later. And this is what Nilakanta is saying. Its planetary model is also cosmologically similar to what is called the Tycho Brahe model, where all the planets go around the sun and the sun goes around the earth. So this is a text which was published in 1955, Aryabhatiya Bhashya of Nilakanta, its third volume. But it was not known that it had a new planetary model till scholars looked at it in 1990. Etaduktam Bhavati, Tayoho, he's talking about Shukra and Buddha, Mercury and Venus. Tayoho Brahmanavrittena na bhuhu kabali kriyate. The earth is not circumscribed by their orbit. Tayoho bhadireva sada bhuhu. So the earth is always outside the orbit of Mercury and Venus, which is the main thing. All other planets go around both the earth and the sun, whereas it's Mercury and Venus which only goes around the sun and which go around the sun. And that they appear to go around the earth is because the sun appears to go around the earth. All this is there in Nilakanta. But Nilakanta wrote an important treatise called Jyotir Mimamsa. This highlights the role of examination in astronomy and revision of theories. But there is something very interesting he's explaining, that he says, don't think that you cannot do any revision to Aryabhata's work just because you think that Aryabhata had the great divine blessing and he was sort of endowed with such intellect that he came up with a perfect model. This can never be so. You can always examine even Aryabhata's model. Devata prasadaha mati vaimalya hetureva. The divine blessing is only to enhance the clarity of your intellect. You should not take it that it's a divine revelation. This holds true for all sciences in India. Whereas at the same time, the most scholars in Europe in 17th century, they were doing a kind of new formulation of the sciences, thinking that they were discovering eternal, unchanging laws of the universe to which the creator had sort of put the universe into. So by creation, the creator had created the universe with these eternal laws, and Newton, Descartes, Galileo, and all of them believed that they were discovering these divine laws which were inherently there in nature. And second thing Nilakantha is saying is that these five ancient Siddhantas, Kvachit Kale Pramana Meva Ityavagantamyam. You should realize that they were Pramana only in a particular time. Apicha, Yaha Siddhantaha, Darshana Visamvadi Bhavati, Saha Anveshaniya. So you have to investigate that theory which is in accordance with observations, and that has to be done. Parikshakai Grahanado Vijnatavya. It has to be done during eclipses by people who examine. And therefore, he thinks that when you teach a student, you teach them Grahagati Samarthya Padanameva Shastra Prayojan. You don't teach the science as an end product which is finished. You teach them science as an ongoing process where they have to improve upon what they have learned from their teachers.
Yes.
So now I just want to emphasize that till recently it was thought, till about 50, 60 years ago, that Indian sciences were sort of reached their pinnacle in 14th, 15th century. That's not really true. What has now been found by various historians, but especially by Sri Dharampal, who wrote two monumental books, one on the science and technology in 18th century and one on the education system, in the indigenous education system in early 19th century. Now, one crucial thing, I mean, he has given various articles on various sciences and technologies that the Europeans of contemporary times found very valuable for their purposes, and therefore they are discussing and describing them. So first is this observatory in Varanasi. And this is the observatory that Jai Singh built in Delhi. This is called the Samrat Yantra. And this is called the Jayaprakash Yantra. This is called the Rama Yantra. The Samrat Yantra, this is then in Jantar Mantar, which you normally now see only during protest movements. So this is about 100 feet high. And these quadrants are about 50 feet in their diameter. And these are also 25 feet in their diameter. This is called Rama Yantra. All of them are to observe the celestial objects, and the least count of these instruments was about 1 second, which was the limit of naked eye observations. So these instruments Raja Jai Singh constructed in around 1720. His history is very interesting. He takes over, he studies traditional texts of astronomy when he is about 18 years old. And then he is able to sort of, once Aurangzeb is no more, he is able to hold out against the Delhi emperor. Later on, he goes and does some sort of he makes up with the Delhi emperor Muhammad Shah and gets land for building this observatory in Delhi. He also gets jizya abolished. He organizes various conferences of religious leaders in Galta next to Jaipur. He uses Vastu Shastra to build an entire capital, Jaipur. His capital earlier was Amber, which was near Jaipur. And this was designed by a Sthapati called Vidyadhar Bhattacharya. It has an observatory. It has this Govinda Deva temple, which is the Govinda Deva temple in Vrindavan, which was destroyed by Aurangzeb. And the Murti was taken to Jaipur and installed there. And a Sanskrit college. He performs Ashwamedha Yajna, etc. But another thing, more important thing is he starts updating Indian astronomy. Unfortunately, due to the political situation in India, the North Indian astronomers were not privy to the kind of developments that occurred in Kerala School of Astronomy, the kind of wonderful things that Nilakanta had done, or Madhava's infinite series, his way of calculating sign function very accurately. The North Indian astronomers were not privy to it. Jagannatha Samrat is from Maharashtra, who becomes the Rajaguru of Jaisimha. So they translate the Islamic works and also the European works. The Euclid's element as translated by Nasiruddin Tusi, and he calls it Rekha Ganita. He translates Almagest of Ptolemy, and he writes independent works, and those are based on observations which are conducted in the great observatories that are built by Jai Singh in these 5 places: Delhi, Jaipur, Ujjain, Varanasi, and Mathura. The Mathura one got destroyed during British rule in 1850s. There are others, Nayana Sukhopadhyaya, who translate many other works. In 1730, Raja Jai Singh sends a Portuguese man to Portugal to obtain the latest astronomical tables from there, and he gets them translated into Sanskrit. And there you see that there are versions of that Sanskrit translation which discuss that the orbit is an ellipse and the earth moves and all those things. He gets in the Islamic style a new zij, a new set of tables in the name of Emperor Muhammad Shah. This is also completed around 1730s. And there are various issues he finds, even with the European tables. And this is recorded in his Zij Muhammad Shah. On examining and comparing the calculations of these tables, that is the table of De La Hare and the European tables, with actual observation that he performs, it appeared there was an error in the former in aligning the moon's place of half a degree. Although the error in other planets were not so great, yet the times of solar and lunar eclipses, he found they came out later or earlier than the truth. There is a work of Jagannath Samrat describing what Raja Jai Singh did. Again he says, Swacharya Krita Granthahi Sadhita Graheshu Tatha Yavana Granthahi Sadhita Graheshu Cha Antaram Drishtva. So he saw this discrepancy between both the European text and the Islamic text and the Indian text and the observations. And so, Daivagyan Subhapumanena Apuya Granthaihi Grahakshavede Pravritto Babuva. So he did continuous observation, for which he discovered several new instruments. And the Samrat Yantra, Jayaprakash Yantra, Rama Yantra, Aishwav were the discoveries or were the inventions or the innovations that both Raja Jai Singh and Jagannath Samrat put together. Etesham Kartavyata Prakarastu Madgranthe Siddhanta Samradi. This is the independent work that Jagannatha wrote. Etari Granthehi Grahanam Vedaha Kritaha Tatra Yavanajijataha Sadhitagraheshu Tatha Veditagraheshu Antaram Drishta. So these are the discrepancies that we see. So he is going through European and the Islamic astronomy and constructing observatories. He is also using the telescope, but at that time the eyepiece of telescope was not developed. So accurate observations couldn't have been made with telescope on celestial positions. The interiors of the planets and moons of the various planets could be seen. So Jai Singh is some kind of a Renaissance astronomer as far as India is concerned. And he is also a town builder. He is also very active in re-establishing the Dharmic empire in India. There are other accounts of Europeans in 18th century. Lee Gentil is a French astronomer who saw that when he went to Tamilian astronomers to calculate an eclipse, their calculation of the period of a duration of the eclipse was only 41 seconds too short, whereas the tables that G. Gentil was using was 1 minute 8 seconds too long. Ram Mohanji, that they talked about the widespread practice of inoculation against smallpox. This again occurs in Dharampal's book. Two detailed accounts are there of 1731 and 1767. And this Holwell, who is a member of the Royal College of Physicians there in England, he says, when the before recited treatment of the inoculated is strictly followed, it is next to a miracle to hear that 1 in a million fails of receiving the infection, or of one that miscarries 100. So that is the effectiveness. I mean, it's a figurative way of saying it was extremely effective. And then he refers to this theory, which is not found in the ancient Sanskrit books, that the mediate or acting cause of epidemic diseases is the multitude of animalculae, that is germs, floating in the atmosphere. And these are the cause of all the epidemic diseases, and more particularly of smallpox. This indigenous inoculation method, which took the pustule from an earlier infected person and used it, very similar to today's vaccine that we do today. This was banned by the British because they had discovered the vaccination taken from the cowpox by the end of 18th century. And this was widespread, and people went from Allahabad, Benares, Vrindavan. So this account really is an eye-opener to us even today. Briefly, something on the Indian education system in 18th century, in the indigenous education system, which is there in Dharampal's book. This astronomy and medicine, in 1823 already it was more than 60 years of British rule in Kerala. And astronomy and medicine were still the most important subjects taught in the colleges there. What is interesting is all communities participated in this education system. In Bengal, Adam did a survey in 1835, Bengal, as you know, came under British rule in 1766, and it has extraordinary sort of demographic decline seen in 1770s due to a famine, where one-third of the people died. But even under these conditions, there still were colleges where subjects like grammar, logic, law, etc. were all taught, as William Adam notes. And William Adam notes that the books that were taught then were not just ancient books of Panini or Patanjali or the Nyaya Sutra. They were the latest books of Nagesha Bhatta, Kaunda Bhatta, Aridikshita, the Navadvipa logicians, Jagadisha, Gadadhara, etc. And all the students were taught gratis. Outside students were provided, in addition, free food and lodging by the teachers with the help of local communities. Earlier, there were assignments made by the kings for this. The great University of Navadvipa in 1700 had about 4,000 students and nearly 600 professors. In 1791, it had about 1,100 students, and by 1829, it had 500, 600 students. I will not talk about Navinyaya. I wanted to tell you that Navinyaya does what is called quantification. Quantification is a statement like, for all x, if x is smoky, then x is fire. So wherever there is smoke, there is fire. It is mathematically treated like this in 19th and 20th century mathematical logic. This was unacceptable to ancient the Navya Nyayikas from 15th century onwards. They used ordinary Sanskrit language and created formulae like this. Samyoga sambandhavachinna, Vakmitvavachinna, Pratiyogita nirupita, Abhavadhikarna nirupita, Samyoga sambandhavachinna, Vrittita, Anavachedakata, Dhumatve. Where the idea of for all x, where you are quantifying over an unspecified universal domain, is avoided in a technically beautiful way using the capacity of Sanskrit language and doing what is called an intentional understanding rather than an extensional understanding of a collection of objects. They are able to do wonderful things. Anyway, all this ended very soon. It had already declined from late 18th century onwards in Bengal. And the person whom we know who is responsible for all this, or who can be sort of the pinnacle of rejection of all Indian learning, all Indian knowledge systems, is Macaulay. As you all know, he abused the Indian knowledge system, that the Indian medical doctrines would disgrace an English farrier. Farrier is a horse doctor, I think. In India, even a horse doctor was thought of very highly, incidentally. Astronomy, which would do laughter in girls at an English boarding school. Of course, Macaulay came from a highly patriarchal society. And but the most curious thing Macaulay is saying is that the natives are desirous to be taught English and they are not desirous to be taught Sanskrit. And he is referring to none else than the great Rajaram Mohan Rai, whom we have sort of revered as the father of modern Indian Renaissance, whereas he is actually leading a counter insurgency against the Indian Renaissance that was happening in the 18th century. Here is what Rajaram Mohan Rai is writing to Lord Amherst in 1823. He says, when the government wanted to spend money, we thought they will employ some European gentlemen and teach us mathematics, European philosophy, European chemistry, and other useful sciences. But instead, they want to establish a Sanskrit college. But this can only be expected to lower the minds of youth with grammatical niceties and metaphysical distinctions of little or no practicable use. Sanskrit language so difficult that almost a lifetime is necessary for its perfect acquisition is well known to have been for ages a lamentable check on the diffusion of knowledge. One should not waste dozens of years of their most valuable period of their lives in acquiring niceties of the Vyakaran of Sanskrit grammar. Similarly, Nyaya is a waste of time. I beg your lordship will be placed to compare the state of science and literature in Europe before the time of Lord Bacon with the progress of knowledge made since he wrote. But here he shows a complete misunderstanding of what happened in Europe. Bacon did not say you give up Greek science, you give up the medieval European science and take up Islamic texts or take up Indian texts or take up Chinese texts and learn everything in Persian or Arabic or in Sanskrit or in Chinese. He said we should learn our Greek, learn our Latin, learn our own languages, and we should learn all the knowledge from everywhere in the world, something that Jai Singh was doing. But we should learn it in our languages for ourselves. And in a pan-European situation in 16th century and 17th century Europe, Latin was still the language. Only very few Italians wrote few texts in Italian in 16th and 17th century. And but Rajaram Rai, Mohan Rai is saying the Sanskrit system of education would be the best calculated to keep the country in darkness. Anyway, so all this ended. The study and practice of Indian sciences got totally disrupted during the British rule. But it did not start in a systematic way in our institutions of higher learning. But a lot of work has gone on by Indian scholars in the last 150 years. But much of this has been done on a voluntary basis outside of the institutions of higher learning. But the very large corpus of Indian scientific texts remain unpublished. Even among the published works, a majority of them are not studied for their technical or scientific content. I gave you an example of Nilakantha's Aryabhatiya Bhashya, which was published in 1955, but nobody noticed that it had a new planetary model, which was computationally equivalent to Kepler and cosmologically equivalent to Tycho Brahe. And all these tasks indeed will have to be undertaken on a priority basis by our institutions of higher learning. I will not discuss this huge manuscript wealth that India is still having. Millions of manuscripts are there. But I'll just tell you what is the situation in one subject about which I know it very well. There are more than 9,000 texts on mathematics and astronomy in about 30,000 manuscripts. Most of them are in Indian repositories. Only 450 of them have been edited, and most of them have been edited in the last 70 years, post-independence. Almost nothing was done during the high period of European Indology. But even if 300 have been edited, only 65 in the last 75 years have been translated and analyzed for their content. So out of 9,000 texts, only 450 are edited, 95 are analyzed. So 5% of the total is edited, and of that only 1/5 are analyzed. And so clearly there is an urgent need to reorient our national priorities and give due importance to preservation, digitization, listing, cataloging, editing, publishing, and promoting systematic studies of the large corpus of source works. And this is not just true about astronomy. The situation will be even worse as regarding many other disciplines, including philosophical systems. Training young scholars for undertaking all these tasks should indeed form an integral part. These subjects should not be banished from our institutions of higher learning. They should be an integral part of our institutions of higher learning. They should be taught, courses should be taught, research should be conducted, etc. Now, I will just close with a 2-minute remark on Ayurveda. In fact, during the British period, Ayurveda also saw a great decline. But along with the independence movement, there was a resurgence of Ayurveda. The Kottakkal and Dabur companies came up at the end of 19th century. And a college for Ayurveda came up in Madras in 1905. But most importantly, Indian National Congress adopted a resolution in 1920, the year when the non-cooperation movement was started, that the Indian systems of medicine, Ayurveda, Siddha, Indian Unani, etc., should form the national systems of medicine. And there are various similar developments going up to the Ayurvedic College in Jamnagar. Now, but what is the situation today in India? There are about 10 lakh practitioners of biomedicine or modern Western medicine. There are about 4.5 lakh Ayurveda practitioners. The number of colleges are similar, but the number of students, it's about 3 times of them are there in undergraduate studies in modern Western medicine compared to Ayurveda. About 20 years earlier, these numbers were even more comparable. But what is the annual budgetary allocation for all the systems, Indian systems of medicine, which come under the Ayush Ministry today? In the last 10 budgets, the annual budgetary allocation for Indian systems of medicine is less than 4%. So Ayurveda gets something around 1.5% or something like that. So the entire allocation for Ayush is less than the allocation done for a single institution like the All India Institute of Medical Sciences. But it was in China where the traditional Chinese medicine was actually declared to be a part of Chinese heritage in Chinese constitution in 1949. And they constitute the traditional Chinese practitioners constitute only 10% of the medical practitioners, but 7% of the state health budget is allocated. Health insurance schemes include traditional Chinese medicine. They are also in the national essential medicines list, and it is available in most modern Western medicine hospitals also. And the traditional Chinese medicine forms more than 5% of the curriculum of students studying in modern Western institutions. But there are many, many scholars, international scholars studying in traditional Chinese medicine universities. And during the COVID time, it's recorded in several scholarly articles that the TCM seems to have played a very crucial role both in the successful control and treatment of COVID. So if we are serious about revitalizing healthcare in India, Ayurveda, which accounts for 1/3 of the medical practitioners, and a large number of local health practitioners dies who do not come under our count. That should be duly recognized by the state in all its policies as an important contributor. For instance, during COVID, we have various laws preventing Ayurvedic physicians from treating, though when the patients have gone to them, many of them have found much better cure than in the biomedicine. Ayurveda should be provided with an equitable share. If it's 1/3, at least it should get 10% of the national resources to flourish. And Ayurvedic education, we have to update. This is where Sanskrit comes. The seminal texts, many of them have to be redone. Authentic translation should be done in all Indian languages. And there is much larger corpus of manuscript of Ayurveda, both in Sanskrit and all regional languages. They should be digitized, important ones should be published. More crucially, there seems to be a certain antagonism between the modern Western system of medicine and its practitioners and the Indian systems of medicine. This will go only when they get to know what these medical systems are, how they are based upon the Indian scientific disciplines of the epistemology of Nyaya, the scientific methodology of Indian darshanas, how they have developed. And our chairman is a scholar of the great treatise that Professor P.C. Ray wrote 100 years ago on history of Hindu chemistry, where he describes how Indian chemistry was experimentally a very sound science. Anyway, all our modern medical students should have at least a 2-semester course on Ayurveda based on some standard text like Ashtanga Hridaya and Shankara Samhita, something like that. So the relevance of Sanskrit for integrating India, and am I audible?
Yes, Srinivas ji.
Yes. Okay.
You
So the
speak.
reference of the Sanskrit tradition of knowledge systems for the revival of Indian sciences, for their resurgence and for their growth, and for tying up our society with our scientific enterprise and technology with our scientific enterprise. It's very relevant that we look at Indian knowledge systems, which owe ultimately to Sanskrit, but which are there in all Indian languages also. Thank you very much.
Thank you very much, Professor Srinivas ji, for this absolutely brilliant presentation. And I think just looking at the comments, I think you have very effectively made us recognize the loss that we are living through by not being aware of so much of wealth that is there lying to be discovered by us. So I'd like to request Professor Chattaraj to say a few comments, and then I'll move on to the questions and come back to you afterwards for closing remarks by the chair, the session chair, as well as from you. So, Professor Chattaraj, would you like to add anything? Would you like to share your thoughts at this point?
Ma'am, sorry to interrupt.
Yes, please tell me.
Srinivasan sir, can you please stop sharing your screen first?
I'm trying to do that only, it is refusing to do. That's what I've been trying for the past 2 minutes. Shall I just stop the video for a minute and then start it? Will that help?
Yeah, yes, you could try that. You could just try closing it at once.
Did that help?
No.
No.
I don't know why there is some issue. So I have said cancel to the share, but it doesn't take that. I'm sorry.
No. In the meanwhile, as you're sorting that, would Professor Chattaraj like to just share some thoughts, initial thoughts, and then we'll take the questions, and in the meanwhile, we can possibly try to resolve this issue. Professor Chattaraj? You're muted, sir. You're muted, sir. Could not hear you.
Okay, I am pretty sure that all of you would agree that for the last almost 1 hour or so, we have been literally mesmerized by the excellent presentation by Srinivasji to a successful marriage of two apparently disjoint aspects, namely Sanskrit and natural science. Now, at this, actually, from my own behalf, I have two, say, points to make. One, say, the modern philosophy by Karl Popper, the hallmark of science is through falsifiability. Now, what you presented, that Indian science had the corresponding harbinger of that falsifiability concept of the hallmark of science. And another thing about when you talk about that matrix, the way, excuse me, we have learned the letters, the alphabets. We have some like ka, barga, ka, cha, ta, ta, pa. These are called barga, this matrix form. So, have you noticed that when you go to North India, particularly Punjab and Haryana, for any given burger, if you have a word to put emphasis on that word, the fourth word is generally replaced by the first word. That's what actually I have noticed. Like if you call Ghanta, they will call Kanta. If I call Bhai, they will call Pai. You see, that is the fourth letter of that burger is replaced by the first letter of that burger. You see, all Haryanvi and Punjabi dialect, that is the case.
Srinivasji?
Yes, sir. Actually, many of these grammars of regional languages actually what are called transformation rules. They are transformation rules from what is called the Tadbhava in Sanskrit to the Tatsama in the regional languages. And then further sort of changes that are needed. And in fact, South Indian languages have other special features like the verbs have gender, which is not there in Hindi, in Sanskrit. It's there in Hindi, of course. So these are, and lot of modern phonetics and phonology came in 19th century was based upon these kind of changes which were observed by the ancient Indian grammarians as to how the sound systems move and change over time. And the
no, but I have some confusion. I think in Sanskrit also, if you have any word ending with a or dirgha e, they are considered to be feminine. If they are ending with o or rasa e, they are called masculine. Okay, like Rajarsi and Rajasri.
You're right.
Deborsi and Debosri. You see, so in
very much so, but for words it is not always so. Ikaranta, Strilingas, Ikaranta, Pullingas are also seen.
We know that Sabita. So we unfortunately keep names of the girls as Sabita, but Sabita is not Surya. Yeah, exceptions are there. Okay, please.
Wonderful. Thank you for the comments.
So I'd like to request Subbarao Nagaraji to please ask your question.
Good evening.
Subbarao, can you please unmute?
Can you hear me?
Yes,
evening.
please. Yes.
Good evening, everyone. And it was an excellent and inspiring talk. And we are so proud to have been born in this great nation because so much of contribution from various, philosophers and the good old scientists. I have one small question. Now, Aryabhatta has written a lot, as you mentioned, sir, on astronomy and space-related literature. But has this been explored by NASA and other space organizations to date? Because after all, centuries ago, we even knew pi, the Pythagoras theorem, and the quadratic equation solving, and the whole lot through the Sanskrit literature. This speaks pretty high about our literary magnates in those days. So, what is the contribution of Aryabhatta to our NASA and other organizations? Are they really taking advantage of these theories, or are we just putting them under the carpet? Thank you, sir.
Sir, Aryabhatta wrote mainly on planetary astronomy. He, of course, had sophisticated idea about time and space. He had an idea that time was infinite, anadi ananta, but it is actually measured by the movement of the celestial bodies. So there is a time scale associated with the stars, time scale with the sun, things like that. He did not have a heliocentric planetary model, but he said that it is the Earth which rotates. And he gave the analogy, which we call as relative motion, that just as if you are in a boat, you see the banks receding. If you are moving in a boat, you see the banks receding, but it's the boat which is moving. And so in the same way, the skies which are standstill are seen to be rotating around us, around the poles, the celestial pole, by us, because it's the Earth which is rotating. But there were various arguments his contemporaries gave to say that this may not be a reasonable theory. There were people who supported Aryabhatta. There were people who disagreed with him. There were different schools. Unlike in the West, where there was almost uniformly, everybody said it is too big to think of Earth rotating. So he did various great things, but I don't think he spoke much about the space explorations and things like that. Independent India has named its first satellite after Aryabhatta in 1975, which is, I think, a great tribute to one of it. Is the first astronomical work written by a person which can be dated, and that is 499. And it has the entire corpus of mathematics that we teach in school and that we don't teach in school, and a standard system of astronomy using which you can calculate eclipses, you can calculate the times of full moon, new moon, and other movement of celestial bodies. So this is what Aryabhatta's book contains. It has only 108 verses. The corresponding treatise in the Greek astronomy called Almagest of Ptolemy is printed in about 500 pages. Aryabhatta's 108 verses can be printed in 3 pages. But it needs a great commentary to fully understand all those verses. He is the originator of the sine function.
Thank you very much, Srinivasji.
It's amazing to know how well the those days the scientific mindset was there, and how scientifically the brain was functioning, and people were giving it out in the literatures. Thank you, sir. Thank you very much.
Thank you very much, Subarao Nagarajanji. Thank you very much. I would just like to make an announcement at this point, because we are well beyond time. But so the announcement is this, that tomorrow's session is a little different because of the timing. We have tomorrow's session from 5 to 6 or 6:30, because the previous speaker, Dr. Nandita Krishnan, was unwell and would not be able to do her session. And therefore, we've requested Professor Gauri Maulikarji from the Chinmaya Vishwavidyapita to do the session. And she has another commitment at 7. So she will be doing her session from 5 o'clock to 6:30. So request you to kindly mark that in your itineraries, and please kindly attend it at 5 o'clock, please. Next, I'd like to request Dr. Pillai to share his comment come question on the Baba Black Sheep one. Dr. Pillai, can you hear me? I think there's a little bit of a problem. Dr. Pillai? All right. I would also next, Srinivasan, just for your information, Dr. Pillai is one of our very senior alumni of Kharagpur. He's an alumnus of Kharagpur, sorry. And
all the time.
Actually,
Yes. Hello. Can you hear me?
yes, we can now.
Yes. Can you?
Yes, sir. Yes, sir. Please go ahead.
Yes, we can hear you, Dr. Pillai.
It has again got muted, I think.
Yes, I think it's got frozen.
Hear me?
Your voice is breaking. All right. Could I request Dr. Bhattacharya, Arnab Bhattacharya, to please ask your question?
All right. Professor Srinivas, excellent talk. Thank you. I always enjoy that. So one very quick question. So we always hear a lot about this origin of calculus in India.
Yes, sir.
So apparently these differences were worked out. So can you please comment on this?
No. Aryabhatta talked of sign differences, second order sign differences being proportional to sign itself. So that is the difference form of the differential equation for the sign function. So that was Aryabhatta's. But it is Madhava, they found out the infinite series for pi, what is called the Leibniz series, then the Gregory series, then the Newton series for sine function and cosine function. And they proved all of them with almost the kind of precision that we have in 19th century, where the idea of limit got much better established. The proofs that Newton or Gregory or Leibniz gave were more ad hoc proofs. They compared few terms on the left hand side to few terms on the right hand side and said that this is therefore equal to this. Whereas the Indian theory of infinite series involved real estimation, what we do in what is called real analysis. But of course, they did it only for the sine function and the cosine function. But they knew the method. They could have done it for other functions, but this was done in the context of astronomy. So what is disputed, therefore, is not that their discovery of pi and sine cosine. Earlier, people thought that they used some algebraic geometrical methods, but they knew the idea of limit, they used the induction, they did everything. So all that is now properly recorded once the text called Ganita Yuktibhasha was translated and published. And so now it's just a matter of definition. If you say calculus is only when and the derivative was known from the time of Bhaskaracharya, who talked of instantaneous velocity. That is where in physics also derivative comes for the first time. And Indians were using abstract functions rather than geometrical model to do their calculations. Therefore, they knew derivative of sine function is cosine function. In Nilakanta showed the derivative of sine inverse function is 1 by square root of 1 minus x square. So all this corpus is very highly calculus to anybody who looks at it very impartially. But if you think only Newton's work or Leibniz's work can be characterized as calculus, nobody can prevent you from holding that view.
Thank you. So just one comment. So
there is a book
saying that
Divakaran in both in the Hindustan Book Agency and it's on Indian mathematics. If you see, this argument on calculus is dealt with in great detail. Professor Divakaran is a theoretical physicist.
I see. Okay. No, I was saying that since you're also mentioning that 95% of the manuscripts are not even looked at, so we require, let's say, these new computational methods of automatic scanning and OCRing and all of these things. So we require this synergy between Sanskrit scholars and computational things. So I mean, this is just a thought. I mean,
yes, we should use all modern technology to unravel, but we should use our modern knowledge of mathematics to look at these texts also. That is what is missing as much as using of technology. Till sort of somebody who knows Kepler's model looked at Nilakantha's sort of planetary model, then one will know how similar they are in computational. But if you don't know the Kepler's model, then you don't know just Nilakantha has made some change in the older algorithm. That's all you will recognize. So we would require scientists who know modern science to look at these texts, not that you immediately will get some result in string theory or foundations of quantum mechanics or something else. But you have very, very interesting mathematics that will lead you to equally important things, which you had not noticed. When in 18th century European scholars looked at it, they found a lot of very interesting things which were very new to them. Even Indian method of making steel was seemed very good to them. So this is the situation, and you need to build upon this as much as build upon whatever you have borrowed from the contemporary developments in science from Europe, or later maybe in 10 years from now China may become the leader of science and Chinese may become the international language of science like Sanskrit was for 1,000 years. So we have to have a very open mind. We should be well rooted in our knowledge and have an open mind to examine, as Raja Jaisingh seems to have done.
Yes. Thank you very much. Always a pleasure. Okay.
Professor Srinivas, sir, you rightly said about the open mind. We need to really look at ourselves. The comment I made was that when will we stop learning Baba Black Sheep and Jack and Jill?
Yes.
It has been years. It has been years. Sir, I am a graduate and PhD from IIT Kharagpur, and I am as old as IIT Kharagpur because I was born just 2 years after IIT Kharagpur was born. And I believe that I did PhD on traditional Indian architecture of Kerala, and I wish that I would be awarded PhD in Vastu Shastra, but that did not happen. I wrote everything in Hindi first, but I had to submit in English. See, because I have learned Sanskrit, I know Hindi very well. I wrote everything in Hindi actually, but it was not acceptable. So we have to change ourselves. We have to accept our work in our language. I wanted to make presentation, speak in Hindi, my PhD work, but that could not happen, you know. I mean, यहाँ पे भी मैं हिंदी में बात करना चाहता हूँ, लेकिन मैं जानता हूँ कि काफी लोग समझेंगे नहीं.
नहीं आप बात कीजिए हिंदी में कीजिए कोई
जी हाँ, तो मतलब ये है कि मुझे हमको अपने आप को चेंज करना है, अपने आप को बदलना है. बाबा ब्लैक शीप से लेके हमको काली काली कुकू करती जो है डाली डाली फिरती, ऐसे छोटे छोटे नर्सरी राइम्स को सीखना है. एक्चुअली बहुत बहुत काम करना है हमको. हमारे क्षेत्र में बहुत कम काम हुआ है. बहुत अच्छा लगा आपका भाषण सुन के. बहुत अच्छा लगा, बहुत अच्छा.
Sir, just a brief comment on that. There was another case in IIT Kanpur around late 70s, I remember, when Dr. Sunil Sahasrabudhe wanted to submit a thesis in Hindi. And again, IIT Kanpur, like IIT Kharagpur, would not allow him. Then he tried all things, and ultimately, I don't know whether he succeeded or not. But I had heard about this situation then. Anyway, the issue here is we are missing out on our Indian languages also. I mean, our Prime Minister now is emphasizing that we have to start all our engineering, medical, and all courses in Indian languages. But to strengthen Indian languages, you have to strengthen their link with Sanskrit. You see, even today in physics, the new term is to be borrowed. They borrow it from Greek or Latin. Most of the botanical names, even today, are Latin names. So people don't give up their tradition of science so easily, like we Indians seem to have done in the last 100, 200 years. There's a huge, I mean, when Jagannatha wrote this Rekha Ganita, he devised all names for all geometrical quantities, which we are using today in our geometry books. What Jagannatha did then, there at least something has been done. But we have to see this triple link, the link of our society with our spoken and literary languages. And about 3 generations ago, serious scholars of Tamil or Kannada, ancient Tamil or ancient Kannada or Telugu, were also scholars of Sanskrit, and vice versa. I quoted the example of Achyuta Pisharati, who wrote both in Sanskrit and in Malayalam commentaries and original texts. So this was very common in India. But now everything seems to be opposed to everything else, and English is opposed to everything else, and regional languages are opposed to Sanskrit, and therefore everybody is losing everything. I mean, we don't need to be opposed to English, but English serves a very small section. Even today, when the British left India, the literacy in English was 2%. The general literacy was about 15%. Today, the general literacy is about 75%. And people who have some knowledge of English are only about 7 to 8% or 10%. The census looks at people who have second language capability in English and third language capability in English. This is not more than 7-8%. So this is our situation, and then it's very easy for those 7-8% who know English to know Sanskrit also. The kind of effort you have to learn that, it hardly takes you more effort to know, and then you will be contributing a great deal to the furtherance of knowledge in this subcontinent.
बहुत बहुत धन्यवाद सर.
Thank you, sir. धन्यवाद. धन्यवाद.
बहुत धन्यवाद महोदय. There's another question by Dhatri Bhagini Atra Prashnam Prashtum Ichhati. Dhatri ji, are you there? Dhatri ji, can you unmute and ask?
Yes, I can unmute. Am I audible?
Dhanyawad. Yes, please.
Yes. So I was just expressing my wish as a student in college, as well as even in school, if possible, that if we wish that we had projects like this to, explore and study such wealth instead of, the same old topics like studying like the same systems or writing something on the same thing. So what can we do at this stage to explore such of course, the ones which are in Sanskrit we have
Your voice is breaking, madam.
but the ones which have already been published.
Speak a little slowly.
Okay.
Yes, we will understand.
Okay, am I audible now?
Yes, you are right. Audible.
Yeah. So, what can we do at this stage personally to explore such manuscripts? Maybe not the ones which are completely unexplored in Sanskrit, but the ones which have already been published and they can be studied by us. So, what can we do?
There are scholars who are working on this in India, and nowadays they are also there in some of the IITs and ISETs, etc. Subjects like mathematics and astronomy had a long tradition of study by modern scholars. This was started by a great man called Vibhuti Bhushan Datta in Calcutta University around 1920s. And that tradition, and later on Saraswati Amma, then R.C. Gupta, K.V. Sharma, they are very great scholars. K.S. Shukla and all. So you will find about 20-30 scholars in various institutions. Whereas for a subject like what our chairman has studied, Indian chemistry, you may not find many scholars at all in India. People have not even heard of P.C. Ray's book. P.C. Ray himself did research on Ayurvedic substances. He was also doing chemical industry. It's very rare to find such kind of scientists in independent India. So the way to correct is to become one such scientist yourself. I mean, if you are not able to study it as a student, you learn your science well, but then you try to see what is it that Indians did in that discipline. Apart from knowing what they did in calculus, that's all right, whatever discipline you are good at. I mean, that discipline will have a history in the West. So there it links with various subjects. For instance, modern physics, this classical mechanics of Newton. You read, there's a book by this scholar called Weinberg, who died recently, Nobel laureate in physics. He has shown that it was the science of astronomy that led to mechanics. So what is this link between mechanics and science of astronomy? If you study that, you will know what science of astronomy that Indian state can contribute further in the analysis of mechanics. So things like that, links will be there. Much of computer science is influenced by Paninian methodology. In fact, many people call him the original computer scientist. His was something like a Turing machine or whatever you may call it. So, but there are many, many techniques of Panini. Unless you are taught that, you will not know what he is using. And these were oral techniques. They were not the written techniques. There are various other nuances which are involved in that. And today's computation is going to oral sphere, not just to written sphere. So like that, there are many, many things which we can do. But we are losing all this by not teaching people like you at least something of Indian scientific disciplines as a part of your regular course, which would whet your appetite, and then you could go and learn from more books and things like that. There are lots of scholarly books, but there are very few popular books which are authentic. So the courses will have to be taught by people who have studied this subject. Otherwise, you will be, it's as good as doing a Google search and getting some material. That's how it is. There are lots of scholarly articles and books which you can try, but it will take time to crack them and all that. The language barrier will have to be crossed and various things. But it's worthwhile once you recognize this problem that you contribute something to its solution during your own career as a scientist or a technologist. That is how one can, I think, in a generation or so, we can change it.
Yes, Mahoday, I'm actually following your footsteps. I'm pursuing theoretical physics.
Oh,
Right?
very good. All the best.
Thank you. Thank you.
Sanskritam samyak patatu.
Yes.
Advana bhavati. Kashtam. So, Srinivasji, there's another question by Amuktaji. There are a few questions. What would you like to do? Do you?
I will not quickly. I will not give long answers. I will make the answers short. Let's get them quickly.
All right.
5 minutes on that and finish.
Sure. Amuktaji?
Yeah.
Yes. Please keep your
Good
question
evening.
brief. Yes.
Yeah. No, I was thinking about the calendar systems. We just did with teachers a lot of study on Indian calendar systems, and there are many, you know. So,
Yes.
what is that? Is there a common origin for them? How do
Yes,
they
yes,
vary?
I'll tell. You see, till about 50 years ago, in BSc and in school also, astronomy was taught. This branch of astronomy dealing with the simple motion of sun and moon and the Adhika Masa and the Tithi Nakshatra, all this were taught. And simple spherical astronomy was also taught. Nowadays, we have nothing of astronomy till our +2, except for statement of Kepler's laws. In fact, children cannot look at the sky and identify any celestial object. This is a very un-Indian way of studying science. Indians were always very aware of their surroundings. The Indian calendar is one of the most scientific ones. It's based upon the motion of sun and moon. And there's a solar calendar where sun goes from one Rashi to another. That is called the Sankranti. And there's a lunisolar calendar where the months start either on the new moon day, Amavasya, or on the full moon day, Purnimasya. So all Indian calendars either are purely solar, like in Tamil Nadu, Punjab, Orissa, Bengal, Assam, etc., and Kerala, or they are lunisolar with starting from Amavasya, like in Andhra, Telangana, Karnataka, Maharashtra. They are lunisolar with the month starting from the full moon day, as in UP, Bihar, etc. So these are the three basic types of calendars in India. And if it is lunisolar, there is something called an Achita Masa. And there are very strict astronomical observational rules that if during that month there is no solar Sankranti, that becomes an Adhika Masa. So it's an observational thing. Of course, you can theoretically calculate and see when an Adhika Masa occurs. So this calendar is a very scientific calendar. We don't teach it to our students should know. Whereas it's our ordinary people who normally keep track of what tithi it is, when it is Amavasya, and they even know the 60 years of the Prabhava, the cycle and all that. That's what they remember. So this has even led to a hiatus between the learned people of India and the ordinary people of India, since we don't teach even elements of our calendar. These three systems, they are not very complicated. It takes about, in classes 8, 9 and 10, you spend about 5 classes each. You make the students very well understand. And they will know all festivals and all that. There are few confusions that are popularly prevalent, like what is called the Uttarayana. That is the northern movement of the sun. That occurs always around December 21st by the way the Gregorian calendar is organized. Now we are many places in India, we are performing the Uttarayana rituals on January 14th or January 15th. That is called the Makara Sankramana, sun entering the Makara Rashi. So this I don't think this confusion was there 200 years earlier. People knew when was Uttarayana and when was Makara Sankramana. They are different phenomena, astronomical phenomena. The sun keeps moving northwards for 6 months as seen from the earth, and then keeps moving southwards as seen from the earth. And this was always observed and correctly noted. So this is one of the common misconceptions which prevail, and there are also various panchangas which are printed which do not tally with the observations and all that. That has been a debate going on for 60, 70 years. Many people are just borrowing the ephemeris published by the NASA or whatever. Why can't every university in India publish a Panchang? What is the problem? So in Indian languages. So this can all be done if we think that these things matter.
Yeah.
Dhanyawad.
Thank you so much. Yeah.
There are about a few, three, four more questions.
Please.
I'll quickly run them through.
Yes, this was an important question. I took a little more time to say something.
Yes. We have Krishnapani Kesirajuji who's saying the general argument against the study of Indian knowledge systems and manuscripts is that they would be only part of historical importance. They would only be of historical importance, and that the probability of these manuscripts adding to the existing body of knowledge would be very low. What is your take on this, Professor Srinivasan?
Depends on what
new discoveries and inventions would be possible?
Okay. No, it all depends on what our conception of adding to present knowledge is. The people who are aware of the historical evolution of a discipline are the people who can make fundamental contributions. People who are only aware of what their teachers have taught can only add a small epsilon, a footnote. So most of Indian scientific enterprise today is adding footnotes. where the centers of research are outside of India. And this has been the problem since independence. Whereas at the time of Raman or Chandrasekhar or P.C. Ray or Ramanujan, they did their research. They knew what was going on in the rest of the world, but they thought that they should start some new line of inquiry. Of course, everybody who thinks like that cannot become a great scientist. But if as a nation we think that we should, for instance, there is something called quadratic indeterminate equation, which is studied in number theory. This is a great thing that great Indians had worked from 5th century Brahmagupta onwards. And we have a great algorithm called Chakravarti algorithm. Till 1930, no Indian scientist even looked at it to see that this was better than all the known algorithms in the world. But you cannot expect that that kind of a gold part you will always strike by looking at an older Indian book. But you will see new lines of inquiry, new kind of problems. The way Indians thought of trigonometry is very different. It's not based upon triangles. It is based upon the relations between, it's called Jyotpati, circles and chords. So that is a much better way of teaching angles and trigonometry even in our schools. So there are hundreds of things we can do. But most crucially, whatever mathematics we are learning in our school was done by Indians by 5th, 6th century. We teach it to our students as if it has got nothing to do with our history. Maybe everybody doesn't need to read manuscripts, but everybody needs to know that Pythagoras' theorem was known in India at 800 BC, and the most general statement was given by Baudhaina, and not keep repeating Pythagoras' name as the discoverer. Pythagoras, even there is no record of his having discovered. So like that, there are thousands of things, and especially in school mathematics, we are learning it as if this was a new discipline introduced to India in 19th century or something like that. And so you will know nothing about it. So even in very advanced research, we normally study the historical evolution of that subject. And if you know the corresponding Indian discipline, you will get many, many insights. And in a science like Ayurveda, which has an entirely different approach to the diseases and healing, it's an entirely different theoretical framework. That's why modern medical scientists are so skeptical about it, because they know nothing about it. So, or Indian music, it has a wonderful theoretical basis, which you will not know unless you study the classical texts of musical theory produced in India. And even music departments in India don't teach it, don't study it. So, this is the situation we are in.
Thank you. And what about the frontiers of physics? Frontiers of modern physical.
No, frontiers of physics.
It's frontiers of modern physical theories.
No, frontiers of modern physical theories, we have to do that much of research in them to reach the frontiers ourselves. We are catching others' tails to reach the frontiers. So even if you say something tomorrow, nobody is going to take you seriously. In fact, many places, Professor G.N. Ramchandran did great research in Madras, sitting in Madras University. But he couldn't get Nobel Prize because there were not enough number of people following research during his time. Of course, today his name is very highly acclaimed. So the first thing that should happen in science is to have a nationalist attitude to doing science in India, that we do the best science here. And if we start doing the best science here, we will know a great amount of new thoughts and ideas can come from our philosophical schools of thought, can come from our ancient texts of science, can come from popular wisdom for the case of technologies in agriculture or dyes or medicines, etc. Ayurveda says that the whole world is the teacher of a good doctor, whereas somebody who doesn't want to know anything from anybody, the whole world is an enemy. So we have started thinking of our own tradition as an enemy that will not let you go anywhere in terms of creating a great scientific renaissance in India.
Professor Srinivas.
Yes, sir.
Yeah, can I just add something? Actually,
Yes,
in order to appreciate our Indian knowledge system, in fact, we should have some holistic viewpoint. You see, when the quantum mechanics was being developed, the concept of wave-particle duality came into the picture. Now, Westerners, they had problem in considering how come a particular system be wave and the particle at the same time. Similarly, when the relativity theory came, the concept of space-time came. So how can we amalgamate totally different aspects like space and time? So if you see the holistic picture, Indians didn't have any problem because they knew Ardhanarishwar, you can have a body half of it is male, half of it is female. You know, Nrsimha avatar, half of it is man, half is lion. So this type of stuff, considering the holistic approach, the Indians didn't have any problem in accepting space-time and wave particle duality.
You're right, sir. Even Nilakanta is talking of sun and the 5 planets going around the sun. He has no problem about the 5 planets going around the sun, which was a major issue of debate in Europe in 16th, 17th century. Now, there are two aspects of Indian thought which are creating this situation. In European thought, relativity could not be sort of immediately appreciated because of the idea that Newton's laws were the ultimate truth about the universe. The idea that scientific theories evolve is new to the modern physics of 20th century, whereas it is as old as Bhartrhari in India. That is changed. So this philosophical understanding of science was all absent. This Kuhnian, Popperian ideas of scientific theories and all that are all 20th century phenomena. From 17th century to 19th century, they thought that the ultimate reality of the world was known to them, and they were given in Newton's equations. And even today, most medical doctors believe that if they discover something, they think that it will last for the next millennium, whereas they don't even last for a generation, most of the drugs that they discover. Whereas the Indians have this understanding that scientific theories evolve. But to now apply Indian philosophical ideas to contemporary physical and chemical and biological problems, you should have a model in contemporary physics or contemporary biology, and then have an idea from Indian philosophical basis. You will get maybe something. But that rarely happens. We let the philosophers talk, we let physicists talk, but physicists don't know much of philosophy, and the philosophers don't know anything of physics. So that kind of situation cannot give us. The kind of scientists who came up with the new Einstein had read most of the classical European philosophy. In fact, he was a great follower of Spinoza. And he known about
actually, no. You should not put hard walls between, say, literature, art, science, etc. And reductionist attitude is good. It has value, but not always true. So, if you consider any biological system can be considered to be composed of several chemical systems. So then any chemistry can be considered in terms of physical laws. Any physical laws can be written down in terms of mathematical equations. Now that reductionist attitude, so whatever elements you have in your body, if I give you, it will not give you a living organism. So the reductionist attitude, it has value to solve the problems, to understand it through some model systems, but not necessarily always valid. And that is something what the Indian knowledge system has taught us, and that is what is not known all throughout. So when someone is asking whether it has any value today or not, perhaps you may get a different way of thinking, as you have correctly pointed out.
But they have much more value, like Ayurveda has much more value for curing all the normal diseases than in improving genetic biology today. There are many people who talk of genomics and all that. If we are able to do great work in genomics ourselves in India, if there are 20 centers which have done outstanding work and 1 or 2 Nobel laureates have produced, then I'm sure genomics also will be able to do great work. So all that requires a sufficient sort of quantum of people and a sufficient mass of people who are delving with a community of scientists who are very well versed with all the tools that they are having. But whereas for the society at large, what Ayurveda can give should be given immediately. We need not wait for the new individualized medicine to come through Ayurveda and modern genetics, and then only Ayurveda is relevant. Or yoga will be relevant only if we are able to understand new psychology out of it. They are very relevant in the way they have been practiced in the last 2000 years. That relevance we should recover at the society.
No. It requires acceptance and encouragement. You see, the society, whatever it will feed through various channels, the society in general will accept that. Okay. Yeah. So if you tell today, no, I got some Ayurvedic treatment for COVID-19, and you can show it that, as you told, that if it gives result, whether the theories don't match, so still we can tell people that this works.
I'm sure, but right now the political and social conditions in India are such that the prejudice against our traditional systems are very large. And it is an uphill task to convince people. But that can be convinced by doing more work. Instead of promising them that we will get immediate results in frontiers of science, if we show exactly what they did in ordinary situations, like what the Indian calendar is, and for that you should know the way we understood the motion of sun and moon, it will carry much, much more value to our society tomorrow. We have promised people that we will do a computer revolution through Sanskrit 30, 40 years ago.
Yes.
A fellow called Rick Briggs wrote a paper on knowledge representation. I know all the people who are working on it, who are doing wonderful work. But still, there are only half a dozen universities and institutes which are doing it. Can they ever match the power of Google or the power of IBM to do something, to get a breakthrough in the next few years? They can do if they are supported by the government, by our society and all that. We are not even doing it for things for which, say, Ramanujan wrote 5,000 results, which were available to all of us. None of the Indian universities worked on Ramanujan. But it's only in 1980s and 1990s that Americans and Europeans worked on it and got people who got Fields Medal and Nobel Prize and all that. So, and with Tata Institute of Fundamental Research just published the notebooks of Ramanujan without any comment. This is our situation today, that we don't take anything done by our own people, be it ancients or today, seriously. The moment we understand science is as much a national cultural enterprise as any other enterprise is, our scientists realize, our governments realize, our learned people realize.
No, not that. The first thing we will have to inculcate the habit of appreciating that your new may be platinum, but old is gold. Number one, I have heard even from very highly educated people, they cannot differentiate between Jagadish Chandra Bose and Satyendranath.
Yes, you are right.
And it is a matter of more shame, they were Bengalis.
You are right. You are right. You are right. Very much. No, there are various problems with our institutions of learning and our knowledge systems today. But looking at Indian knowledge systems will give one small corrective and an important corrective.
Incidentally, in IIT Kharagpur, in fact, Anuradha is the stalwart in that business. We have started on a moderate scale say one semester course on history of science and technology in ancient India.
But instead of teaching it as history, perhaps we should teach it as scientific theories or mathematical.
No. As a matter of fact, I teach the chemistry part. Say when I go for history part, say I talk about the zinc metallurgy. I taught in terms of phase rule. So modern phase rule they will know. So I have a connection. So whenever I am talking about say Anu, Paramanu, Tanmatra, etc., I immediately go to quantum mechanics and tell them whatever is to be taught in the quantum mechanics.
Right?
So the connection is always made between the old and the new.
No, it's not so much just the connection. It is that this is also science and that's also science. That feeling should come. That is the kind of thing that you are saying, that we do not have, we have a very reductionist view of science. And that's preventing us from appreciating the plurality of scientific theories.
No. I don't consider both the parties. Who is telling everything is there in Veda? I don't like that. At the same time, nothing is there in Veda. That also I don't like. So what I try to do, I bring in the old stuff. First you learn this. Without learning, don't pass any comment. And then I tell these are the things which were exactly what we are teaching now, modern contemporary science. And these are the things which were perhaps not.
No. Both the people who say everything was there in the past are nothing is there in the past. Don't want anything to change in what is happening in India. What we are keen is that the Indian intellect should revive once again, looking at the world and understand that we have great contributions to make in future.
No. India has a big problem. It's a large country, so many types of people. So if you want to create any ripple, too much of inertia is there. And the second point is whatever new you try to inject, that would immediately get dissipated in that large mass.
No, no, look at how Europe had Renaissance. They learned from the Islamic books, they learned from the Chinese books, Indian books. Their greatest technological innovations, compass, this gunpowder and all this were printing were all taken from China. But Deccan thinks these were the great new things. But it was just within 2-3 generations. Of course, they were trying to conquer the world also at the same time. So in these 2-3 generations, they took their own ancient science and borrowed from various people. They created a new scheme, which they internalized as their own new scheme. They were later on not referring to the Chinese or to the Indians or to the Islamic texts. They moved their own. So I'm sure we will also be able to take whatever we need to take from our older books, whatever we need to take from the contemporary sciences in many areas and move forward. But if we are not done the exercise, we keep saying that this has not been done, that has not been done. Whereas once we do it, it's a matter of 1 or 2 generations. Once we
No, there are many such things. You think about zinc metallurgy.
I know.
So that metallurgy was known only in India.
And
but now, yes, but now nothing is there. So we are borrowing everything about zinc metallurgy from abroad.
No, borrowing is not wrong as long as you understand it's a transitory phenomenon. We are wedded to borrowing perpetually, and that's our problem.
So if I may...
Anyway, I think it's high time if I have something to tell. So, in fact, on behalf of everyone present around, I would like to extend my heartfelt thanks to Professor Srinivas for this excellent, talk on which he could just tell so many different things in such a small amount of time. Thank you so much.
Thanks.
Thank you very much, sir, and thank you very much for that very invigorating discussion and debate at the end. Thank you very much, because I think the prana came alive, and we getting down to maybe actually seeing how we can go about doing something about it. It's not just about talking of, yes, it's very good, but how do we get on? What are the integrities? What are the challenges we face in even trying to bring something? Because there is also this very big discussion about language. So we are discussing in English, and there are positions that say, Hariramji and all are saying, Hindi mein baat kijiye. But then we'll have the Bengali spirit coming up and saying, why not in Bangla and Bengal? Why in Hindi in Bengal? It's such a multifarious problem that we are faced with, especially the linguistic aspect of it. So I would just like to, there are still 2 questions, but I think we'll request them to send you the questions. No? Mrigendra ji, yes. So we'll stop here. And I request, I've shared Professor Srinivas's email address. So please feel free to write to him, and he'll reply to them. There was just one question about when you would offer your NPTEL course again. Maybe we could announce that for the audience, because then they might want to register for that course.
No, that was a one-time course which is on the web. We should do a course on Indian astronomy that we are working, but it will take a little time to do.
But would you re-offer that so that people can even get credit in terms of...
That is people who are currently in education. We are all retired people in some sense. So, so Ram Subramanian, you have to ask day after tomorrow.
Okay. So thank you very much. Maybe I'd request you for your closing comments, and then I'll request Piyush to just say...
It was wonderful having all these questions and having this beautiful discussion. I don't have any answers. But I have a lot of concerns which I have shared with you, and some suggestions which I think may take us to a much brighter future than our present. I am not very unhappy with our present. We have done fairly all right. Mahatma Gandhi said it takes 150 years of British rule. At least it will take 75 years for us to get out of our slavery and the efforts, the effect it has had on every cell of our body politic. So we are nearing our 75th year of independence. So within a generation, we should stop worrying about the rest of the world and our following. We should try be on terms with the rest of the world, and we are as good as them. We don't need to be world leaders, but we should be performers on par with everybody else, given our capacities and propensities and the effort that we put in. Thank you very much.
Thank you very much. And yes, so I'd like to just thank you, and also to thank Professor Chattoraji for his time and for having accepted to chair the session. Sir is very active in our course on history of science and technology in ancient India, as the discussion revealed. So thank you very much, and we look forward to your guidance, your continued guidance for any kind of activity that we would like to undertake at the Center of Excellence for Indian Knowledge Systems. So thank you very much, sir. And just one last reminder that tomorrow's session is from 5 to 6 p.m. So please mark that in your calendars and in your schedule, that is from 5 to 6. And the topic that we are going to be addressing is Sanskrit and sacred ecology. So we are trying to look at the extent of environmental sciences that are being discussed in Sanskrit texts by Dr. Gauri Maulikar ji. So thank you very much, and look forward. Punarmilama Mohdaya. So thank you. We'd like to just end with the Shanti Mantra. So I'll just, Piyush, I'll just do the Shanti Mantra. Okay. So we can end with the Sarve Bhavantu Sukhina. So please join me in saying it. The recording is available. Kuldeep ji, could you please share the link for where the recordings are available on the chat
Yes.
so that people can catch up with them, please?
Yeah.
Yes. So we can just end with the Shanti Mantra, which is Sarve Bhavantu Sukhinam. Om Sarve Bhavantu Sukhinah Sarve Santu Niramaya Sarve Bhadrani Pashyantu Ma Kaschit Dukkha Bhavet Om Shanti Shanti Iti.